Many laborers are fighting hard against the violent ocean currents to complete the construction of an underwater bridge pier. But wait! Can you spot a critical mistake made by the chief construction engineer? This mistake will lead to a catastrophe. Welcome to the world of civil engineering's most challenging task, underwater construction. But what if I tell you that modern engineers actually avoid water altogether when building underwater structures? Let's explore the incredible world of cofferdams and how they make underwater bridge construction possible. Welcome to Civil Engineering Edge. In this video, we will go through the world of civil engineering's most challenging task, underwater construction. Cofferdam Engineering, the secret to building bridges underwater. Let's get started. Introduction to cofferdams. Before we dive into the construction process, let's understand what exactly is a cofferdam. A cofferdam is a temporary enclosure built within or across a body of water to create a dry work environment. This allows engineers to construct bridge foundations, piers, or other marine structures efficiently. Cofferdams are essential in underwater construction as they keep the construction site dry by preventing water intrusion. But how do engineers build these giant watertight structures underwater? Let's break it down step by step. Step 1. Site investigation and planning. Underwater construction is not just about brute force, it requires precise planning. Before starting the cofferdam, engineers conduct a geotechnical study of the soil to determine its strength. The most common test used for this is the cone penetration test (CPT), which measures soil resistance. Based on these results, engineers decide how deep the cofferdam must be anchored to ensure stability. Step 2. Installing guide piles. The first visible step in cofferdam construction is installing guide piles. These vertical steel pipes are driven into the seabed using a pile-driving hammer machine. They serve as a framework to align and guide the sheet piles, which will form the walls of the cofferdam. Without these guide piles, sheet piles may not align properly, leading to water leakage and structural failure. Step 3. Driving sheet piles. Now comes the crucial part: installing sheet piles. These steel sheets with interlocking edges are driven deep into the seabed using a vibratory pile driver. But have you noticed something special about this machine? It doesn't just push the sheet piles down, it vibrates them into the soil. This high-frequency vibration reduces friction, allowing the sheets to penetrate deep without damaging them. The piling process starts from the corners and moves toward the center to maintain alignment. Once the sheet piles reach the bedrock, the cofferdam's outer shell is ready. Step 4. Strengthening the cofferdam. At this stage, we have a temporary barrier, but it is still weak. The single-layer sheet piles alone cannot withstand the immense water pressure. To reinforce the structure, engineers create a double-layered cofferdam by installing another set of sheet piles parallel to the first layer. The space between these layers is then filled with sand, gravel, or broken rock. This adds stability and prevents water seepage. But is this enough? No, a bracing frame system is installed inside the cofferdam. These horizontal beams, called struts, connect the walls and resist inward collapse due to water pressure. Without these braces, the cofferdam would fail under external forces. Now, we're ready for the next step. Step 5. Water pumping and dewatering. With the sheet piles and bracing system in place, it's time to remove the water. High-powered pumps gradually extract water from inside the cofferdam. But suddenly, disaster strikes. Water starts seeping in from beneath the structure. This phenomenon, known as bottom heave, occurs when water pressure forces itself through the soil under the cofferdam. How do engineers solve this? By constructing a concrete seal course. Step 6. Building the concrete seal course. The solution is simple but effective. First, workers remove loose soil using clamshell buckets operated by cranes. Then, large hollow steel pipes are driven into the bedrock to anchor the foundation. Using a tremie pipe, specialized high workability concrete is poured underwater. The concrete displaces the water and settles onto the seabed, creating a watertight seal. Once cured, this layer blocks further water seepage, ensuring a dry work site.
Hello guys, watch this video and enjoy yourself. Please don't forget to share, like and comments on this channel and subscribe to watch the next video.
Step 7. Constructing the bridge pier. With the foundation secure, engineers begin constructing the bridge pier. High-strength reinforced steel bars are arranged, and concrete is poured into the structure. Since this pier will be permanently submerged, the concrete mix is carefully chosen to withstand water pressure and erosion. After 14 to 28 days, the concrete gains full strength, and the pier is ready to support the bridge. Step 8. Cofferdam removal. Now that the bridge pier is complete, what happens to the cofferdam? It's no longer needed. Engineers carefully dismantle the upper sections of the sheet piles. However, the portion embedded in the concrete seal course is left in place to maintain structural integrity. This marks the successful completion of the bridge foundation. Required machinery and barge boats. Cofferdam construction requires specialized machinery and barge boats for efficient and safe operation. Let's go through them step by step. 1. Pile driving hammer machine, used for installing guide piles and sheet piles by driving them deep into the seabed. This machine ensures the structural stability of the cofferdam. 2. Vibratory pile driver, utilized to drive sheet piles into the seabed using high-frequency vibrations, reducing resistance and preventing material damage. 3. Clamshell buckets, operated by an excavator. These buckets are used to remove soil and debris from inside the cofferdam before concrete placement. 4. Auger machine, used for drilling through hard rock to place steel pipes that anchor the foundation securely into the bedrock. 5. Tremie pipe system, a long, segmented pipe used for pouring specialized high-workability concrete underwater without mixing with surrounding water. 6. High-powered pumps, essential for dewatering the cofferdam and keeping the site dry by continuously removing seepage water. 7. Flat surface barge work barge, a floating platform used to transport heavy equipment, machinery, and construction materials to the worksite. 8. Crane barge, a barge equipped with cranes to lift and position large construction components, including sheet piles and heavy reinforcement materials. 9. Tugboats. These small, powerful boats help maneuver and position barges at the construction site. By efficiently utilizing these machines and boats in a step-by-step manner, engineers ensure the successful construction of bridge foundations using cofferdams. Benefits of cofferdams. Cofferdams offer numerous advantages in underwater construction. They create a dry work environment, ensuring safety and efficiency for workers. This method significantly reduces construction delays caused by water currents and tides. Additionally, cofferdams provide a stable platform for heavy machinery, allowing precise and high-quality construction. They also minimize environmental impact by containing debris and preventing water pollution. Overall, cofferdams play a crucial role in ensuring the durability and longevity of marine structures. Safety precautions in cofferdam construction. While cofferdams are essential for underwater construction, they come with significant risks. Engineers must follow strict safety protocols to prevent accidents. Proper bracing and support systems must be in place to resist water pressure and structural collapse.
and
Regular
subscribe
inspections
to
and
watch
monitoring
the
of
next
water seepage are necessary to avoid sudden failures. Workers must use personal protective equipment, PPE, such as helmets, life vests, and harnesses to ensure their safety. Emergency evacuation plans must be in place to respond to unexpected flooding or breaches. By adhering to these safety measures, engineers can successfully complete underwater construction projects without hazards. Conclusion: from planning and installation to construction and removal, the Cofferdam plays a crucial role in bridge foundation engineering. Without this temporary structure, building stable underwater foundations would be nearly impossible. The next time you see a massive bridge spanning a river or ocean, remember the incredible engineering that made it possible. If you found this video informative, don't forget to like, share, and subscribe to Civil Engineering Edge for more insightful videos on civil engineering marvels. See you in the next episode, where we will explore another fascinating topic in construction engineering.